In this talk, we are proposing a protocol that is using the Bitcoin blockchain as a way to implement an end-to-end voting system. The paper is by me and other three authors. Francesco Santini is one of my collaborators, and Mantilacci and Santancini are two students of mine. So, by the way, this paper is not in the proceeding because it was already presented at the symposium applied to computing last year, so it's presented not to be included in the proceeding. So if you want to have a look at the paper, you have to look at the proceeding of SAC. So in this talk, I will first give some summary on how is defined a voting system, and in particular how is defined an end-to-end voting system. Then I will give you, unfortunately for you, some small notion about Bitcoin again, and then how we implement this end-to-end voting system in Bitcoin blockchain. So voting system can be characterized as two phases. On the first phase, we need to authenticate the voter, because usually not all the people can be a voter. And in the second phase, the voter is admitted to the casting and transmission of the vote. And also there is another phase, not in this slide, that I will also speak about, is about the computation of the results. Why the idea was using blockchain? Because for sure e-voting is an interesting topic, and also for saving money during the election and so on, but also today's implementation of e-voting is not always so safe, so secure, or guarantee confidentiality or other. So it is an example of the Estonia voting, where the password was just in the wall, so everyone can know the password that can be used for access to the system. So, and there is also other criticism to some voting platform. One of these is the extreme centralization of all the system. This means that this become a one single point of failure, and this is a very problematic stuff. And the other two things are correlated. One of these is that there is no transparent poll. So this means that the people is authenticated, can go to make the votation. And after this step, you have completely to trust all the system, because there's no way to check if really the vote is computed, what happened to this vote. So this is very, unfortunately, not so nice things for people going to vote. So what we like to do is to try to remove all this weakness with our protocol. This is the definition of end-to-end voting system. So it's a voting system that permits to the user to take care of what happened during the votation process. So to check what happened of the vote, if this vote is computed in the overall results, and so on. It is not the first attempt, by the way. There are other implementation, not using Bitcoin blockchain, by the way. So one of these is Helios, for instance. Yes, Bitcoin is, many people here probably already know, this is an important one, and not important as the blockchain is, but really maybe more famous than the blockchain one. So Bitcoin was famous essentially for this for motivation. Is a way to perform peer-to-peer transactions without third party involved, and they can be used for payment with low processing fees. It was defined in 2008 by this famous guy Satoshi Nakamoto that defined this paper, and the first implementation came from, since it is alive from 2009. It was changed in Bitcoin Core in last maybe 2 years ago. So before Bitcoin, every process, also voting, for instance, needs to consider to rely on a third party. So, for instance, for Bitcoin, when you want to make for normal payment, if you want to make a payment, you have to rely to a bank, to some PayPal server, Western Union, or what else. And the idea that you have to trust this red guy because he maintains the database of all the transactions. the main idea that stay on the back side of the Bitcoin technology is the fact that you really can do peer-to-peer transaction because, and without third party, because every peer has a copy of the database, so you are sure that it's impossible to modify what is written inside the database without other people realize that it will be modified. And also another characteristic is that everything that is written in the blockchain can never be changed. So it's not possible to change your vote when it's inserted in the blockchain. This is the idea. So this is a global view of all the environment. We could speak maybe 1 hour only with this slide. So I will just give it just some small detail. Let's say the node that make the protocol alive are the node that maintain a copy of this distributed database, distributed ledger, and normal user can participate to the protocol just using a wallet that uses to maintain essentially the key of the user. And when a user wants to make a transaction that is send money to someone else, what he can do, he just send the transaction in Brockstar to all the node, and the node insert the transaction inside this distributed database. This is the very, I lie a lot to say this one, but this is just the minimum things that you need to know. And so the idea, if Alice want to send money to Bob, just create a transaction, taking some of his Bitcoin, one for instance, and send it to the public key of Bob. This transaction is broadcast to the peer, to the node that have the copy of the blockchain, and all the transactions are collected in a block, and then a new block is created, is maintained forever in this distributed ledger. So the idea that we have is why does not consider a transaction as a votation process. So when you want to vote, just send a Bitcoin or a Satoshi, that is just a small amount of Bitcoin, to another one. And this was the first implementation that we have. So we have to decide how to implement all the pre-voting phase, the voting, and let's say the counting of the results. For the pre-voting phase is the most important. The pre-voting phase is the most important phase because you need first to register which are the candidates. So in order to decide if a specific transaction toward this public key is valid or not. So this is just normally, to do this, we just create a list of public key that represent the candidate and are officially associated to the candidate. The next phase is to register the voter. So you need to give a token to be spent as a vote to each one of the authorized people to vote in this votation. And I will give a detail on this because, as usual, we don't want to make clear who is the guy that is giving the transaction. So from one part, you want to authenticate the user because you want that only authorized people can participate to the votation. And on the other side, you want to be sure that it's not possible to create a connection from the user and the token using the transaction to give the vote. To do this, you make two implementations, by the way. One is used the anonymous Kerberos, and the other one using some blended signature. This, by the way, is we did not invent anything. We just use these two protocol, and I don't need to give in detail about this one because it's already old stuff. And the main idea is that the protocol, both of them, permit to demonstrate that you are authorized to vote without showing who you really are. in this case, you make this separate the fact that you are authorized to vote, but when you send the vote, people cannot link your identity with the Bitcoin. Okay, then we are at the voting phase. So each people go throughout this authentication step, receive a token by some authority. By the way, the authentication is in two phases, because for one phase I say only people that can be voted need to receive the vote, and then only the received token can be spent for the vote. The casting is really easy. The casting just perform a transaction from your keys to the key of the candidate, normal transaction. You can use any wallet for this. And then the transmission confirmation on the vote consists just in the broadcast of this decision of vote, this transaction, to all the nodes that maintain the blockchain. And as soon as your transaction is inserted in the blockchain, you are sure that your vote will be counted, will be computed at the end for the final results. So the idea is casting of the voter and broadcast to all the nodes. And your transaction will be inserted in the blockchain after a while, by the way, not immediately. And at the end of the votation period, you can just count how many transaction has been received for each one of the candidates in order to decide how many votes this candidate has received. Yes, this is the candidate. Just looking at this, the public key of the candidate, we can just compute how many votes is received. We also make a different implementation. Instead of just using Bitcoin as the token to be sent for the voting, we decide to create a colored coin. That is a way just to define a new asset related to the Bitcoin. But the idea is that instead of really sending the money, you are doing a special operation. This is an operator that is an operation that is not giving really money, but it's just write something inside the blockchain. And what is written inside the blockchain is an hash, an information that can be interpreted as the sending on the asset. So the asset that we create was called coin vote, and we use the coin prism as a colored coin, but many other can be used, coin spark, sparkbit, any. We make also some computation of the cost of an election when using Bitcoin or when using colored coin vote was the name. And you can still, because as you say, the transactions will remain on the blockchain forever, you can still go there and check that this operation were made using the blockchain. And by the way, because I say that this transaction has no meaning, this is, by the way, this is coin prism. You say that a specific coin vote has been sent to a specific public address, public key address. And if you go to blockchain, you can see that it's impossible to check the output because this is an open return, and obviously you didn't send any money to anyone. So this is the complete architecture of the system. There is on the pro-voting phase, we have some a web interface that I will show later, where the user can authenticate and all the stuff that I show. Then he can vote. All the votes are put on the blockchain, and then we can easily counting the result. For the counting, by the way, if you use the standard Bitcoin transaction, everyone can go and check the balance of the address represented by the candidate to check how many token he received. And instead, if you want, if colored coin is used, you can just go on the application. In this case, Coin Prism, and check the Coin Prism balance of this asset. So it's really easy in both ways. Property that has been satisfied by the protocol are all of this. I will try to describe the property and say why the property is satisfied. So is eligibility and authentication are easily satisfied, because to do this we use this authentication phase using or blended signature or this version of Kerberos, that is anonymous Kerberos. Verifiability and auditability. It is possible to verify that all the votes have been correctly accounted in the final tally, and this can be easily done because you can just check in the blockchain, in the blocks, what is written inside, and you are sure that it's not possible to modify what is written inside the block. Uniqueness. Since you accept as a correct votation only the token that are being delivered from the authority to the authenticated user, only this token has been considered legally vote. Okay. Integrity. The blockchain ensures integrity, so it's not possible to modify it. Vote anonymity, since the authentication is not performed directly by using this blinded or anonymous Kerberos, this is a guarantee. Counting and recounting means that anyone can count and recount again the results of the votation, so this is easily. But there are two properties that are not satisfied. Which one? These two. Unconsiderability and receipt freeness. Since we want to have counting, recounting, verifiability, auditability, it's not easy to prove unconsiderability. Unconsiderability is the property that we really want in an election, that I cannot make an obligation to some guys to make a specific votation. If you go with a gun and say, you have to vote this one, I can check if really this guy made this vote, because I can check in the blockchain what he voted at the end. So this is not so good. Data confidentiality and neutrality. Not only I can check if my vote is counted at the end in the global result of the election, but everyone can check it. It's sure that there is no connection between the key and the user, but in case you want the people to, you with the gun show that give me your key, then you can check the vote and all the process. So this is not nice. To do this, before giving about some note about how to solve this one, let me show you some interface that we have, just a very small interface where we have yes, this is the menu where I want to decide if I want to do pre-vote, vote, or post-vote. This in the pre-vote is I get the asset or the coin, depending if I want to use the color of the coin or not. And then I can vote, select the candidate. You see there is the key, the public key, and I can perform the vote. And then I can check for each one of the address the total number of the vote. This is just a very small interface of the system. The important part is the engine, it's not really the interface, but just to show that something exists. I say that two properties are not satisfied. The two properties can instead be satisfied. We can use a smarter blockchain than Bitcoin. To say the possibility to check really and to give access to specific user to specific right on the blockchain. To do this, we are currently, it's not finished yet, but we are currently implementing all the systems that I described, not in Bitcoin, but in multi-chain, where some specific right can be considered. So the interface is pretty the same, nicer, because it was smarter, the student, by the way. And this is the pre-vote phase, the vote, and so on.